Formation of an image due to multiple reflection of light. Click on the links provided. Principle: if an object is placed between two plane mirrors inclined at an angle, we get more than one image due to multiple reflection of light. The number of images n obtained when two mirrors are inclined at an angle theta is given by the relation n is equal to 360 divided by theta minus 1. If 360 divided by theta is not a whole number, then the number of images will be rounded off to the nearest integer. When the angle of inclination between the mirrors is 120 degrees. You can see here that when two plane mirrors are kept inclined at 120 degrees, only two images are formed. Go through the mathematical proof given here and click on the button to see the ray diagram. Image formation when an object is placed between two mirrors inclined at 120 degrees. Place the mirrors mm and mm' in such a way that the angle between them is 120 degrees. Now place an object O in between the two mirrors. Let OA and OB be the rays incident on the mirror MM. OA being perpendicular to the mirror retraces its path. Whereas OB gets reflected along BC according to the laws of reflection. Extend the reflected rays AO and BC backwards. An image is formed at O1, the point of intersection of these reflected rays. Let OD and OE be incident on the mirror MM'. OE gets reflected along EF according to the law of reflection, and OD being perpendicular to the mirror MM' retraces its path. Extend EF and OD backwards. The point of intersection O2 gives the position of the image. Thus, when the angle of inclination is 120 degrees, we get two images. When the mirrors are mutually perpendicular to each other. When two mirrors are placed mutually perpendicular to each other, we obtain three images. This can be mathematically proved using the relation n is equal to 360 divided by theta minus 1. Click on the button to view the animation. Image formation when the mirrors are mutually perpendicular to each other. Place an object O between two mutually perpendicular mirrors. OA and OB are the two rays that are incident on the mirror MM. OA, being normal to the surface, retraces its path. OB gets reflected along BC according to the laws of reflection. Extend the rays OA and BC backwards. They meet at O1. O1 is the virtual image of the object. OD and OE represent the rays that are incident on the mirror MM-. OD, being normal, retraces its path. OE makes an angle I with the normal M- and gets reflected along EF according to the laws of reflection. Extend the reflected rays OD and EF backwards. They meet at O2. O2 is the virtual image of O. The reflected ray BC gets reflected internally by the mirror MM- along CG. The ray CG appears to come from O3, which is the image of O1. Similarly, EF gets internally reflected by the mirror MM along FH. The ray appears to come from O4. O4 and O3 coincide. Thus we obtain three images when an object is placed between two mutually perpendicular mirrors. When two mirrors are placed parallel to each other, you can see here that when two mirrors are placed parallel to each other, infinite images are formed. Image formation when an object is placed between two mirrors placed parallel to each other. Let MM and M', be placed parallel to each other. Place an object O in between the mirrors. OO' represent the rays incident on the mirror MM. The ray OA makes an angle I with the normal and gets reflected according to the laws of reflection. OO', being normal to the mirror, retraces its path. Extend the rays AB and OO' backwards. They meet at I1, which is the virtual image of O. The mirror M', reflects the reflected ray AB. Extend OM' and BC backwards. They meet at I2 to give the virtual image. Similarly, the images I3, I4 are formed.